The last big topic of this unit is talking about the trajectory that a bullet takes through space. So that's the path that the bullet goes through from space, from when it leaves the barrel of the gun to when it strikes in its final target. In order to determine trajectory, we need to have at least 2 reference points. Those reference points could be things like a hole in an object, a wall, a window, a desk. It could be an entry or an exit wound that's in the victim. It could be the location, the height of the shooter. Anything like that can help us to kind of reconstruct the crime scene. So when they have these 2 reference points, like in the victim, they would put like what's called a trajectory rod. We used those when we were looking at the bullet holes the other day, through those, and they can trace the path that that bullet took in order to get to that point. So obviously if you look at the green path here, it's more angled than the blue path. So that the 2 reference points, both the entry and the exit wound, can help us trace that point of the path that that bullet took through space. In order to do the calculation that we're going to use to determine things like the distance of the shooter and the height of the shooter, we have to go to do a little bit of math, and we're going to use trigonometry. So we're talking about triangles. For our purposes, just to simplify it a little bit, we're only going to use, I'm only going to test you on bullets that are in the floor. So let's say that we have a bullet hole right here. The person shot the bullet down at that angle. So we have a bullet hole in the floor. If you remember, there's 3 different formulas you can use when we're dealing with a triangle. There's sine, cosine, and tangent. So for each of those, you need different parts of that triangle, either the opposite, the adjacent, or the hypotenuse side. We are going to stick with the non-hypotenuse side. So we're not going to actually look at the path that the bullet took. So C in this would actually be the path that the bullet took. We're going to look at B and A, and sides B and A. And since we're dealing with a bullet hole down here, A is going to be the opposite of that, and B is going to be the adjacent line for that part of the triangle. So since we're dealing with opposite and adjacent sides of the triangle, we are going to be doing the tangent function. All right, so there are 2 main formulas that we can do. We are going to either look for the location of the shooter or the height that that shooter is. Normally, when we do a triangle like this, we are going to use what's referred to as the shoulder height of the victim. So if I look at my triangle set up, over here we have the bullet hole, the distance that the person was standing is the adjacent, and then we have our person standing here. Okay, so they're standing here with their weapon in their hand. Now, if you think about the way that a person holds their weapon, they are going to be holding that weapon at their shoulder height. Right, so if we look at this guy who is holding the rifle here, if I draw the line from the barrel of the gun is approximately equal to his shoulder height. I don't want his head height, right? We're not going to be shooting from the top of our head. So we're not going to use the head height of an individual, we're going to use the shoulder height. Generally speaking, on average, a person's neck and head are approximately 10 inches. So whenever we go to figure out a person's shoulder height, we're just going to subtract 10 inches from their total head height. So when we go to solve this, you will have a known value for the angle of impact. Either you're going to use a trajectory rod or it will just be given to you in the question. You're going to be given either the distance of the shooter or the shoulder height of the shooter, and then you have to solve for the one that we don't have. Today what we're going to focus on is the one where we're going to be determining the location of the shooter. So you're going to have 2 known values, the angle of impact, so we'll be able to figure out the angle that that bullet struck, and we're also going to have a suspect. So since we have a suspect, we're going to know their shoulder height. The unknown value for today is going to be the distance that the shooter was standing. So we're trying to reconstruct the crime scene, maybe figure out where they were standing so we can go find the shell casings or whatever it can be that we're looking for. There is a formula that we're going to use. The good news is that you don't have to memorize it like all our other formulas. It is in table B of your reference table, and it's dealing with the tangent. I've rearranged that tangent equals opposite over adjacent for you, so all you have to do is plug numbers into the formula. So let's try one of these together. So if we look at this practice problem that's in the middle of the page, it tells you that a bullet hole was found in the floor of a victim's bedroom. A witness saw a 6-foot man with a shoulder height of 5'2" or 62 inches leaving the victim's house after a gun was shot. The angle of impact for that bullet hole was 42 degrees, so calculate the distance that the shooter was standing. So the first thing that you should do is label all of the known things that you have on the triangle that's drawn. Like I said, the bullet hole in here is in the floor. So we're looking down here at the bullet hole. The question tells you that it is 42 degrees, so we're going to label this guy right here as 42 degrees. And they tell you that the man is 6 foot tall. And I actually already did part of the math for you and came up with the height of this guy, shoulder height, of being 62 inches. So what I'm solving for is this letter D. So let's set up our equation. So from that formula, we know that the distance is the height, the shoulder height of the person. So from this case, it's the 62 inches over the tangent of the angle of impact. For this question, it is 42 degrees. When you go to plug this into your graphing calculator, make sure that you are in degrees and not radians. If you have a graphing calculator, you can just plug this straight into the calculator. 62 divided by the tangent of 42, whole number is perfectly acceptable to round your answer to. If you do not have a graphing calculator and you are using one of my scientific calculators, you are probably going to have to figure out what the tangent of 42 is and then divide that decimal. So if I do just 62 and then if I plug in my tangent of 42, it comes out to be 0.9004. So I can plug that in for the tangent of 42 and then just do 62 divided by 0.9004 to get that distance of 69 inches. So this tells me that this shooter was standing 69 inches, so over 5 feet away from the bullet hole that was in the floor. So now as an investigator, I can go over and look in that area and try to find fingerprints or hair or cartridge cases or anything that can help me figure out who this man was. All right, so what we're going to do is one more practice problem. I'm going to have you do this on your own and then check a key with me in a few minutes. I just want to point out that when we see this on our test next week, this is going to be at least a 3-point question. You will get 1 point just for setting up the diagram. So labeling that triangle with the known value and the unknown value, that should be a super easy point to get. And then you will get at least 2 points, depending on the type of question that we have, for showing your work and also coming up with the correct answer. So please make sure that we are doing lots of practice with this, because there will be several of these on the test and they will each be worth a few points. So try this, you try it question. Call me over if you have any questions. Once you have an answer, go back into Schoology, into the task, and you can look up the correct answer to make sure that you are on the right path. Once you complete this practice problem, you can pick up the angle of impact and distance of the shooter practice problem and work on those.